Hello, AP Stats. Last little bit of Chapter 7 notes, and in this page, we're dealing with residual plots. We haven't mentioned anything about residual plots before, so this is brand new, and this is also one of the most important things when we do linear regression. What residual plots are is this is a scatter plot that helps determine whether linear regression is appropriate. So if you remember, one of the conditions for running linear regression was that we wanted our data to be linear. And I mentioned that right up here, right? We want linear data, not curved. So sometimes we can see, obviously, within the original scatter plot that the data is curved, and we can say, okay, so we shouldn't use linear regression here because the data is curved. Sometimes it's not so easy to see, though. And that's where these residual plots come in handy. So the residual plots help us determine if we should use linear regression. All right, and specifically, if it's appropriate, you'll see random scatter. And if it's not appropriate, so if we shouldn't use linear regression, you'll see a kind of a curved pattern. And here's what this could look like. So maybe we have a bunch of points below, then above, and then below again. So a residual plot is when you plot, instead of looking at your original scatter plot where you have X and Y, here's an example. We could have, let's say this protein, let's say this is X, and instead of looking at Y, this is now residuals. So it's a graph, it's a plot where your X list is plotted against your residuals. And sometimes this could be your Y coordinate, your Y variable. It doesn't matter as long as you're plotting against your residuals. So I recognize right now, a lot of this doesn't make sense. You're like, what the heck is he talking about? Trust me, it'll start making a little more sense once you see this in example. So in this case here where we see a residual plot, we know it's a residual plot because residuals are one of the axes. You have this line going across at 0. And we see that there's like, if you look at this scatter plot, it's pretty random. So in this case, since the residual plot shows randomness, it is appropriate to use linear regression. And if there's anything I want you guys to take from today, guys, is like, what the heck is a residual plot? Why do we use it? All it is another plot for the same data that helps us decide, should we use linear regression or should we not use linear regression? All right, so here's an example, number 1. All right, guys, so continue with number 1 here. We want to create a linear model for this set of data, and this data shows the change in tuition costs at Arizona State University in the 1990s. So 1 represents the year 1991, and 2 represents 1992, and then so on. So we want to create the linear model and then check whether the model is appropriate. So So here we have years, really since 1990. And then here's tuition. So I'm actually going to skip the step where I put all this into the calculator. I hope we have gotten to that step, but for video purposes, I only care about the last piece. So I'm going to put this into my calculator, put this into list 1, put this into list 2, made sure my stat diagnostics were on, and did stat, option number 9, linear regression. I got an equation that if I round to the nearest, let's go 2 places because we're talking about money. Here's what I get. And if I did plug in the variables, we can say the predicted tuition, it's the same thing. Just plugging in years since 1990. All right, so we got that. And then also my calculator gave me a correlation coefficient of 0.99. And it gave me an R-squared value of 0.98. So I did want to talk about these two things. Just kind of a refresher. Remember, the correlation coefficient, or the R value, tells you 2 things. In this case, this tells us, hey, we have a really strong and positive association. And what does our R-squared value tell us? Well, this is the really strange thing in statistics. It's like, it tells you one sentence, and I don't want to get into the actual, like, explaining what the sentence does. It's a cookie cutter formula. I've asked many stats teachers in the past, like, why do we even teach this? They don't know. So we just kind of do until it stops showing up on the AP test. But this R-squared value is 0.98, but remember, we'll always see it as a percent. So we'll say 98% of the variance in Y, our Y variable, which is tuition, can be explained by the variance in X. And X would be years. All right. So what we've learned so far, guys, with linear regression, if you can follow what we've done so far, like, you're in a very good spot. Like, we have data set, we have 2 quantitative variables, we take the linear regression model that the calculator gives us, we have a correlation coefficient, we have this R-squared value. And remember, this R-squared value, I hate saying this as a teacher, but, like, don't worry too much about, like, why this is what it is. That's probably, like, the only time this year you'll hear me say that, but just try to remember how to write the sentence. And then this correlation coefficient tells us that we have a strong and positive association. And then we don't have anything with residuals here, but if you just remember that this equation is made because our calculator figured out a way to minimize the residuals. And this is the line that has the least residuals. All right, so that's awesome. We have all this. Now, the new thing for today is we got to check, is this model appropriate? And what we need to do there is we need to look at the scatter plot of the residuals. Now, I spent about an hour making this video because I tried 2 different calculator apps and neither of them work for residual plots. So I'm just going to, for this year, I'm going to give you guys the residual plots, and you're still going to have to interpret them. You're just not going to have the skill of making your own residual plots. And as we get closer to the AP test at the end of the year, we'll come back to that, and I'll make sure that you guys are knowledgeable on how to use your calculator to make residual plots. But for now, here's what I want you to know. I used my calculator, and I plotted our X and Y, that's just like these guys up here. And what I saw was like a pretty strong and positive linear association. So it looks something like that. Probably stronger than this even. All right, and your calculator shows you what this looks like, so you can actually get to that from that. But that's what I'm saying. I had some troubles with that. So this is what you call like your original plot. It's just your original data set, right? Now, the residual plot, something different. The residual plot is when instead of having a y variable, instead of having that second list plotted here, you have your residuals plotted. And then the bottom over here, you have x. And you can actually get to this using your calculator. And again, I wish I could show you how, but for now, it's okay. And when I figured out what the residual plot was for this data set, I got something that looked like this. All right. And what this tells us here, guys, is that we have a pretty obvious pattern in our residual plots. Remember that residual plots, what we want is randomness. Now, looking at this residual plots, this doesn't look random. There's a clear curved pattern where it's like above the line, below the line, above the line. So what that tells us, guys, is that over here, over here, we actually have a curved line. And maybe it's not so obvious in the original plot, but that's why we look at the residual plot. The residual plot, what it essentially does is it just magnifies the pattern that's happening over here. So in the residual plot, we can clearly see that there is a curved pattern to this relationship. So based on this residual plot, this linear equation that we came up with is not appropriate for this. So I'm going to say this. Since there is a clear curved pattern in the residual plot, it is inappropriate to use a linear model. So we won't get into curved models, but maybe an exponential model or even a quadratic model might be something that's more appropriate. But since we see this curvedness right here, we know that we should not be using a linear model. All right, guys, that's it for residual plots. So just remember, residual plots, we make them because they tell us should we or should we not use the linear regression. All right, guys, a few 1, 2, 3 questions to check for your understanding. All right, the second one here, looking at this residual plot, what can you conclude from this graph? So is a linear model appropriate or is it not? And then the last question, looking at this residual plot, what can you conclude? Is a linear model appropriate? Yes or no?